question is, did I change my vehicle dynamics for the two cars? I'm not even at that point yet. So you would absolutely. And the thing that I'm very interested in, and it was certainly something that I invested in doing the calibration for the omnidirectional camera, is that I think that the system should be able to calibrate itself and learn its own parameters, and not have to add in a bunch of special numbers. So I'm very excited about enabling it to kind of learn where it is and learn how the car is configured. You said.
Could you, well, are you planning on making a bigger car? Not like one that you could actually drive, are you planning to make a bigger model of it?
So I do have a Power Wheels Bigfoot that you could actually sit in and drive around. That's a robot in kind of the same vein. But what's really great about having a small car is that it's cheap. If you have a big car and you crash it, you've got to spend a lot of money fixing it. And having a small car is great because all of the parts are relatively small, and when it hits something, it doesn't really break that bad. You said.
Are you gonna use the lighthouses in a big room eventually and drive it around?
So what I do is I back the minivan out. And I drive it around inside of the garage. This is a picture of it driving a circuitous route inside of the garage. So this is in meters. What I'm able to do is just have the two lighthouses, just mount them in the garage all the time. And anytime that I get the chance to back the minivan out, I'm able to do some testing and training inside of the garage. That was the main thing that I wanted to do with making the car smaller, was specifically so that I could actually do a turn and actually go in actually have a course within my garage, within that footprint.
Yeah. How did you kind of calibrate your column filter at its variance values? Did you use the lighthouse system to try and estimate those variance values, or did you just randomly guess?
So
Repeat the question, please.
Okay, sorry. So how did I calibrate my Kalman filter? At this point, I'm still at a point of understanding Kalman filters where I'm actually just putting in the actual values and waiting for it to settle. So you can actually see, and here is the actual training, the actual Kalman filter kind of coming to a quiescent state in this beginning kind of run-up within about 60 iterations. If you, as I understand it, as I've been playing with the Kalman filters, if you can get the covariances close enough, if you get those general parameters close enough, it'll converge to something that will function for you. I'm still learning that.
You chose to use your cameras in some kind of image processing rather than LiDAR?
Correct. So I'm not a fan of LiDAR, just from the standpoint of I think it's cool tech. I think it's still expensive. But I'm very excited about trying to use vision over LiDAR because I think it's the future. So I'm very interested in trying to solve those particular problems.
Just to step back one bit to the Kalman filter and the tuning, have you
Sure.
considered using any AI or machine learning to help you tune those parameters?
Absolutely. So using MPFit is actually a great little library for doing least squares, and what you can do is run the entire Kalman. So this is recorded data. You can run your entire algorithm through it, give it some kind of cost function, and then ask MPFit to go through and here's 9 values that I want you to play around with within these ranges, and it kind of determine the best value. It's an accepted approach. It's a great idea.
Yeah, because I just last fall I actually worked on a project to use reinforcement learning to tune expect the range error out of a turning vehicle, so that it would make like smooth turns.
Yeah, absolutely. So again, using a least squares approach, MPFit was the library that I used. I used it many times in the process of like calibrating where I thought the lighthouses were, for example.
So I wonder if I'm trying to solve a similar problem. What I'm using is Aruco markers on the ceiling. I think, I need to verify, that with a Raspberry Pi and their standard camera, Aruco markers about every meter on the ceiling, that I'm getting errors on the order of under 1/8 of an inch. cheap, easy to do. In my case, it's gonna be accurate enough. I don't know if it would be accurate enough for what you're trying to do. Do you really need 7mm?
So
Or is that just a good benefit you're getting?
it's a great benefit that you're getting. I think millimeter accuracy is actually important when you think about the noise. If you can get it off of this platform, very, very kind of helpful. But if you imagine, like you, at any point that you're trying to calculate your own velocity or your acceleration from your position, like your, whatever error you have, if that's a half an inch, like that turns into something squared in your velocity, squared in your acceleration. So the tighter you can make it, the better you're off. Your implementation at speeds, depending on what you're trying to
Very slow
solve, may work just perfectly. You said.
If it's training in the garage, will you need to reach? How will it know what to do outside when you take it outside?
Are you talking about the lighting conditions?
What?
Lighting conditions. So whether or not it's bright outside or dark outside, like it's raining outside.
No, but like you said that you're practicing, that you're training it inside the garage. So how will it know where to go when you're doing it outside?
I think you mean so your lighthouses are on your van, I guess?
But so one thing that I can do is you can actually get tripods for these lighthouses, and you can set them up in different areas. They are IR based, so if they're out in the sun, they'll get bleached out by the sun itself. But that's just a training piece. What I expect is that I'll be able to get to some point with the training data within the garage, and then I won't need the lighthouses.
That approach looks a little bit like, if you look at another way, it looks like inverse LiDAR.
Yeah.
Okay. I had a question on the FPGAs. Is the software that's being used, is that locally done package, or is it, how does that compare with the Diamond software that comes with Lattice?
So my experience is with the Altera kit, but generally what Clifford is doing is pretty remarkable from a standpoint of being able to deliver a tool chain that is as fast as it is that compact that it is. I think he's just coming from it from a perspective completely new, and that at least with my experience with Xilinx and Altera's kit, it's been built over years and years and years and hasn't had a rewrite in a very long time. It's gigabytes. So I'm sure the Lattice stuff is fantastic. From my perspective, being able to use a freely available kit right out of the box was really cool.
Can you repeat the name though? Clifford something?
Clifford Wolf
And there-
and Yosys is the package.
How do you spell Yosis?
Yosys is Yosys. APIO is a package library that actually adds those together, combines those as a tool chain together. Specifically, if you look at Tiny FPGA, that's a great introductory piece of hardware, and he's using essentially all of the Yosys and APIO stuff. Tiny FPGA.
Let's have one more question.
Yes.
So, thank you for the content. There's a lot of content in there. I was wondering if you could make this available?
This slide is on Google Slides, and I'll put it on the HRBC.
Excellent. Great last question.
Yes.
We need you to come back in a few months and give us an update on how you're doing. All right, so that's the end of the meeting. We have this room